Let me give you guys some more practice. So this is an acceleration time graph for any object free falling on planet Venus. So on planet Venus, the g of Venus is 8.87 meters per second squared. So you can just go on the internet and look up this figure. So the acceleration will be somewhere here, 8.87. Okay. What I want to know is if if I drop a cannonball on Venus, what will be the distance traveled after six seconds? So looking at this, all that you know is that when you drop something on Venus, the speed will increase by 8.87 every second. Now, in the previous video, I kept on saying, oh, there's not enough information to work this out, because you need to know the speed the speed when time equals zero. You need to know the distance when time equals zero. You need to know this. You need to know that. Well, in this case, in this case, you can work out the distance traveled after 6 seconds, because the reason why you don't need it in this case, you don't need to know the speed when time equals zero. You don't need to know the speed. You don't know the distance. The reason why you don't need to know these things here is because, well, because it's rooted in the language here. Because I said, if I drop, now if you imagine you standing on, this is Venus here, Venus, and this is you, and then you're going to drop a cannonball. You see, the reason why I didn't state all these initial conditions is because I said if I drop, well, if I drop something, then the initial speed here is zero. So it's rooted in the language. So I don't need to explicitly say that, oh, speed equals zero when t equals zero, because it's in the language. I drop. If I say, oh, I threw, or well, if I said I dropped, so the speed would be zero. Or if I didn't say I pushed it downwards, or I threw it downwards. I said I dropped. Okay, so if I drop a cannonball, meaning that the speed would be zero. And also I said the work out the distance traveled. Well, I think you know by just using the language, work out the distance traveled. It means that the distance, the reference point is from here. So from the reference points is from the top of the building. So if I say the distance traveled, it means the distance from the top of the building. Because the reason why I didn't state all this is because it's rooted in the language. You can get all the pieces of information that you need from the whole sentence. Okay, so I'm going to drop a cannonball on Venus. What will be the distance traveled after 6 seconds? So this is all that you're given. Hang on, let me move this up. Wait there. Let me move this up so that you can pause it and then you can see the question. Okay, so yep. So hang on. So now when I pause it, when you pause it, you can see the question. So remember, I've given you the acceleration time graph, and inside your mind, you should visualize this. I've given you the acceleration time graph. Remember, inside your mind, always visualize the three graphs. So speed, time, distance, time. This is most of the time it's useless, this one. You really want to use this one here, speed to time graph. So I've given you the acceleration, a weird acceleration, 8.7, blah, 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 blah. So because there's an acceleration of this, you know there's an increase in speed, and that this gradient here is the acceleration. So you can say y equals 8.87x. In this case, it's s equals blah blah. S equals 8.87 t, if you like. You can use this or this. Okay. Well, once you've got this here, I said, what is the distance traveled after what? After 6 seconds. So here after 6 seconds, just sketch yourself a speed time graph, and then what is this height here? What is this height here? Well, this height here will stuff this into this thing here, and then the s here will represent the speed at time equals 6. Okay, it represents the height, and the across here will be 6. So work out the area underneath here, and that will tell you the distance traveled after 6 seconds. Or you can use that magical formula, gt squared over 2. You see, this is actually the same as working out the area underneath the speed time graph. Well, do whatever you have to do. So here, press pause and have a go. Okay, so given this acceleration here, so inside your mind, visualize this. Your acceleration time graph. This is 8.87. So your speed time graph will be this. Okay, y equals 8.87x. That's the equation of a straight line. And then sketch this here, even though you don't need it. It will look something like this. Okay, you probably won't need it. So well, yeah, we want to know the distance traveled after 6 seconds. So what is this height here? Because we need to work out the area underneath the graph. So stuff this into here. So this height here will be given as 8.87 times 6. So calculator, 8.87 times 6 equals. So the height will be 53.22. So after 6 seconds, the speed of the cannonball will be 53.22 meters per second. Okay. Now the across here is 6. So if I want to know the area, I would get this times this and then divided by 2. I'm just going to get this times by 3. Okay, because whatever times 6 and then divided by 2, I'm just going to merge these two together to create 3. So the area underneath this thing here, I'm just going to get this times 3. Okay, hang on, calculator, and then times. I'm just going to times 3 rather than times 6 and then divide by 2. So the distance traveled after 6 seconds will be so hang on. Actually, we do well. So after 6 seconds here, after 6 seconds, this height here, well, this point here will be what was it? 159.66. Okay, so after 6 seconds, the height here will be, well, that represents the distance traveled after 6 seconds. Okay, so this here is your answer, and the answer would be meters. Okay.